We will continue. This is script 002 out of 1001, and we're going to be doing grasshopper definitions and showing how experimental things can be and how you don't know where things are going to go and try and complicate the simplest of simple things in a sense of having a bit of a creative spark. So I'll move my head over here. I just like my head over here on top of Max's little farm because I can have multiple arms, which I think is a pretty positive attribute. Anyway, so here we go. We're going to go on in, and like I said, I'm going to treat it the same way. We're only looking at circular arc, curve, and line, and seeing how they can inspire us to make scripts. And they actually do. So we're going to leave it, I think, off. So I'll have to click things. And those, and I've got it paired up with these little links. What are they called? Jump tools. So they'll jump over to wherever I'm using it, and we can just scoot around and see how I could activate these into scripts. Let's start simply with the circular arc, which basically think of a circle as an arc that's closed. So generate circular arcs, generate an arc, but in generating an arc, I decided instead of just having one, I brought in 3 planes, which is nice with the merge tool. You could plug them in just by holding down shift, but I find the merge tools are better because if you ever wanted to disconnect one, it's the same kind of way. Now there's 2 arcs, but I like the 3, and they're prescribed, getting a sense of understanding the planes and where things are, and then generate them by always, I love radians. I'm always going to deal in radians. Degrees to me is, grade 10 math, and radians is grade 12, so it's not that much different. The radius is here that you can play with, varied. These are pretty basic tools, but you'll see the generation of kind of this circle, which is really nice, this sphere, and there it is. Starting from radians at in 3 different directions, how to make a sphere from just points extending across lines. I think that's pretty fun. And of course, in the sense that at any point, it's not a circle, so it wouldn't read as a circle, but at any point, this can be interpreted as a circular arc. I flattened them all and said, okay, well, let's do something with an intersection tool, which is where I have another series going through intersections, teaching that, ABCs and 1, 2, 3s of Rhino, Grasshopper for Rhino. This is nice because it shows the intersections. It shows the points. It shows me the indexes that say, yes, we're intersecting, or no is a Boolean. And it shows the params on a, keep in mind that I have to reparameterize these curves from 0 to 1. So I'm constantly going in and reparameterizing things. That then will show me those points as they connect to those curves. And at what point between 0 and 1, where do they connect? And I probably should stretch that out so it makes a little more sense for a param viewer. And then that's data. Think about using that data now to grab exact points on curves to link to geometries like, say, centers of spheres. So it's not hard to take that data and then, boom, pop it into another geometry and start connecting things. Nice little example of working with circular arc. Let's go down to curve. And what did curve inspire me to do? Well, curves have always, this script I love generating. I just find it the most interesting thing out there. It's helixes. And they're 2 different sizes here. And the only difference between them is they're constructed from points. Sometimes the grouping actually gets me very upset when I try and select things. But let's just move that. Let's select that 2 curves, one inner, one outer, which are directed from these points and these points, which I can make more of a count or less of a count. They are basically an amplification or multiplication of a sine and cosine curve coming from a range of points, and that's it. Points that are can be interpolated there and there. And I can magnify them or shrink or enlarge them. And they should be connected to that amplification too. I'm wondering why that one didn't provide too much change. Where have I disconnected things? Y amplification. Oh, because that Z factor is, you can see that I have a problem. I have this outcome running Z, this one going to Z. Well, I did something that it doesn't, the amplification doesn't process through for some reason. That one shouldn't be going up there. That one should be going to X is there, Y and Z are being switched. So sorry, I'm just slowing down. My brain's kind of turned to mush right now. I think I really want that Y in there. And that's going to change everything to what I had. So I think I actually like the geometry I made, even though it was accidental. I had an inner curve and an outer curve, and just have to go back till I get it. I think we have it now. There, the inner and outer curve. So that's an accident that led to different geometry, because that geometry led me to want to put them into curves. So now I have the curve tool working, and I decided to, on a YZ axis, 4 times, revolve them. And you end up making rope, pipe rope. And in taking those 2 curves, I have to keep remembering this. I'm going to take the group off because the grouping does become a problem later on. You've got those two groups that can be lofted together. Now, keep in mind this ribbon tool and what's happening in it. Not only this is complicating with the polar array, and I'm not going to go further with that. Let's keep it simple to this ribbon tool. Now, I want you to look at that and see how those lines were lofted. They're basically made up of this line and this line lofting together. Keep that in mind because we're going to try something a little different here. These two lines lofted, do that. And look at that geometry. I want you to see a different take on this. If I take this point, these set of points, if I shake this down, the points, and I go to a curve closest point, and I take a reparametized curve from that interpolated curve, and I switch them up on two separate curves, this one and this one, and I draw lines between them, I have all these lines. Now, these lines follow the same path. It's like flipping a matrix on information. These lines and these lines, this set is being lofted lengthwise this way, and let me take that off, and the other set is being lofted from these lines in this direction. And that's where I really end up with, and I'm considering looking at line. What's nice about lines is you have to reparameterize them to make them work. If you do not reparameterize your curves, what I end up doing is taking both surfaces, and I'll talk about this in a minute. I take that reparameterized surface and that reparameterized surface as an evaluate surface at a point right in the middle. We're going to end up with 2 points. And what do we end up with? We end up with this point in the middle of this curve, this curve and this curve. Now, they look very similar, but they're not. They're lofted from those lines in different directions. And to show the difference between them, I'm going to take those two and say, okay, this is the point in the first one. It's very subtle, but there's the shift. And it's just, if you watch that point, it just moves a tiny bit from where it was. So you got this one over to this one. You could technically draw a line between it to change it. If you look at a vector tool here and you say, okay, there's the normal direction. Well, look at the normal direction on this one. It's reversed to what that one is. It's perpendicular to that one. If you take a look at the UV direction, there's the U direction, there's the V direction. And if you take a look at the V direction and the U direction, you'll see that they're actually swapped. And if you take a look at the planes, you're going to notice that those actually have shifted in the process of what's happening as well. So don't think dealing with the same points, if you draw the lines, that the loft tool is going to be any bit similar. Well, it's going to be similar, but technically there's two lofted forms on here that if I took off one, you'd see a little subtle difference. And if I put back on that and took this one off, you'd see a little subtle change. So kind of hard to see, but just showing you a little bit of use in creative exercises for building in geometries, analyzing, because it's one thing to build the geometry. Yes, people could just put in a line here or a curve and say, okay, I'll import a curve from here, here, and I'll pop that in. That'll be my geometry. But that's a type of CAD production I'm not interested in. I'm interested in generative art, parametric art, algorithmic art, computational art. How can you really get an advantage over other people that would take 15, 20 minutes to change a model, whereas you can change a model in a matter of split seconds. And that's the strength of this. And I'm not sure if this is that's my polar array, so I'm gonna have to go over here. How can I have total quick parametric control that's not dependent on anything in Rhino before I even bake it, that I can start grabbing geometries like this and thinking about what I would do with them. Wonderful little ribbon tool. And also, what a wonderful ribbon tool to think of fabrication, breaking this into a mesh and thinking panels. I'm not sure why you'd ever want to make this shape, but also the world that's happening in here is something that excites me. We're at the 5-minute mark, but I'm going to take this to bake. And we'll go yes, okay, and then I'll leave this. I like to click this item and leave. And then I'll drop out a grasshopper. I've got another Rhino window up for some reason. I'm going to go into here and just look at it from all sides. And one thing I like to do is just pull it into a fast little render, not ray traced, a fast technical, which allows me to see it on different levels. And you'll get in the habit with me getting used to me seeing this, because I love these renderings and drawings. And for somebody that drew so much, for the sculptor, yes, what you think is infinite, hopefully. What you can draw is less than that, or what you can talk about is less than that. What you can draw is even less than that. And the chances of fabrication and making something, as I take this over to pen, iterations and drawings are something that I've been doing for decades. So what a tool to jump in and play with this. Anyway, I hope you liked it. And I will just go back to pop up the Grasshopper script and let you see how that kind of played out. And we still have yet to go through all these simple params. I'm just going to do 3 at a time. And hopefully by the time I'm done this list of all these wonderful params, maths, sets, vectors, curves, surfaces, meshes, intersection transformations, and displays, we've got 1,001 simple scripts to play with. And that's going to be pretty fun. And if not, we'll go into plugins. So thanks very much for watching. Hope to keep following followers, and I hope to do this free for anybody who needs the resource to delve into this. You know, I watched a lot of videos at 2 times speed or 1.75 speed because a lot of cool ideas come up. I may pop the odd plugin in here, but it's about being creative. It's about getting lost, finding new things that nobody else has discovered. Maybe they have, but you haven't discovered them. We're all working on the same human project, so this is part of it. And any artist can work as a conceptual exercise with any technology thrown at them. So there's no reason not to feel capable of that. Thank you for watching.